Somebody signed the wrong spot.
I think your IP agenda is here.
It's early morning.
I looked at it.
Okay, good morning. Welcome to the Collaborative Automated Course of Action BOF, also known as Cacao, I believe. Is that the right way to pronounce it? Heard a couple different pronunciations, but so you guys, I'm sure this is Friday morning. The note well, if you're not familiar with it, then there's probably a problem, but here it is for you. I think next slide. Go to the. So our agenda is going to be pretty simple today. We have all of our administrivia taken care of. We're going to have a presentation on the kind of problem statement and the space that Cacao is looking at, and then we'll go to making sure everybody kind of understands what that is, and ask some questions of the group as to how we should move forward. So I think we'll ask Brett to come up and start the show.
Thank you. So I wanted to spend some. So we're here this morning to talk a little bit about Cacao and what it means from a security defense, cyber defense perspective. And I want to first start talking about, do some basic level setting, talk about the why. Why is this important? What is the problem statement? You know, why is this an issue in modern day SOCs, Security Operations Center? And kind of what is a proposed solution. So the why, what, how of this aspect. I just do some basic level setting. I know not everyone here actively works in a SOC and may not have a lot of familiarity with what goes on day to day from an operational standpoint. Note well, so note the note well. So, noted well. So Alan Thompson from Looking Glass, Jody Verma from Cisco, and myself, Brett Jordan from Symantec, have been working with a large group of individuals for about 18 months, trying to find a potential solution for this space. We've been working with a lot of large enterprise, a lot of banks, a lot of governments, trying to look at a different way that we could potentially solve this. We did a lot of work to flesh out the possibility, and then we got to a point where, okay, now we need to take it to an SDO and try to see if we could standardize it so we could do some interoperability. We could guarantee that different systems and networks and components and stacks could be able to consume these things and do whatever. So we decided we'd try and come here to the IETF. We felt that this group would have a lot of great experience and a lot of things, especially when it comes time to do the picking of a protocol and those sort of things. So on the problem statement, just to do level setting, as you know, and as you probably read through a lot of the information that comes out, threat actors and their intrusion sets are advancing and they're becoming more prolific. An intrusion set, for those that aren't familiar with the term, if you don't come from the IC, the intelligence community, is basically a collection of all of the tools and capabilities that exist that make up an attack or attack framework. Those intrusion sets can be used, by different threat actors. Those threat actors can come and go. They can be sold off and used by other ones. And over time, intrusion sets do actually change and morph. But an intrusion set, a lot of times in the commodity literature, they refer to them as an APT, like APT1 or APT2, those sort of things. And I think the most important thing is the amount of time available for organizations to respond and to keep themselves adequately protective is decreasing. So, when we look at like the Lockheed Martin kill chain, When you go through the reconnaissance phase, a threat actor group may spend months and months, years doing investigation, doing, reconnaissance, and then it takes minutes to compromise the network, and then they're typically in the network for months to years. Okay, so the defense is manual, it's slow, it's very reactive, it's very siloed. Various parts of the group or various parts of the organization don't typically talk well with each other, and especially if you're in a larger enterprise where you have different business units or different enclaves, you have a lot of coordination that needs to take place. And there's really not a great way currently to share, playbooks, run books, courses of action across these groups, and there's no way to collaborate on them across a trust group or an ecosystem, or like a vertical sector like the telco space or financial services or healthcare. Okay, so I drew a little picture here to kind of help everybody kind of understand kind of what this would mean and what this would look like. So on this problem statement, if you look at where a compromise might come in and how it would proliferate throughout the network. So say it comes in across a mobile device, and then it moves laterally through the organization. It'll hit endpoint devices, it'll hit IoT devices, potentially security cameras, move through the network, compromising servers, compromising applications, and going on. The point from this work from Cacao is that all of these different groups need to be involved through the mitigation and remediation of this attack. It's not just one person or one tiny little group. So you're going to have, the mobile engineering, desktop engineering, you're going to have network support, you're going to have network engineering, you're going to have security, operations, and these playbooks, they have to be shared and be communicated, and a lot of work has to be done. Today, playbooks are in prolific use. They're used in nearly every major SOC on the planet, so this isn't a new concept. The difference is a playbook is typically written down and put in a binder, or put in a PDF, or put in like a knowledge base article, and there's no way for these playbooks to be collaborated or shared. And since it's in a knowledge base article, a lot of organizations think that, oh, this is a trusted knowledge, we don't want to share this, we don't want to leak information, we don't want to work with other entities in this space. So I wanted to help try and do some level setting and talk, maybe some pictures might help express that. So what is Cacao? It's a collaborative, automated course of action, or a series of operations for defense, for cyber security, cyber defense. It's not for physical security, so we want to make sure that we're not talking about that space. While this design could potentially be used for a lot of other spaces, we wanted to not boil the ocean, and we wanted to focus on a pretty narrow problem space. So it deals with the creation, distribution, and monitoring of the execution of the individualized actions that would be part of an overall playbook. So the goal with a playbook and all of the individual actions is to prevent, mitigate, remediate a threat, and then also to monitor to make sure that the actions were processed correctly and make sure that the threat and attack has actually been mitigated. So the hope and the goal of all of this work is to build upon a lot of existing technologies that are used either here in the IETF or out of other SDOs. So I could see like individual actions making use of I2NSF or NetConf or DOTS or other pieces that are done either here, like I said, in the IETF, or that are done in other SDOs. What Cacao is not, it's not a standard for sharing arbitrary content or data. This is not about documenting indicators of compromise, threat actor behavior, documenting an incident. And like I said, the hope is that it could make use of a lot of other technologies that already exist when it comes time to define the individualized actions. So as I said, playbooks today, they're security processes, they involve procedures, there's technical, there's human capabilities. And I can have an example here in a second, but sometimes part of the playbook might be, call this individual if they don't respond within 20 minutes, call this individual if they don't respond in 20 minutes, call the CIO and get them out of bed. Go and block this on the firewall, and then go in and block this on the proxy, and then start working your way down through the network. Because as you know, deploying solutions or mitigation or remediation steps across a large organization takes a lot of time. All of the endpoints aren't necessarily always available, and so you rely on the various network pieces to actually to get this done. And so all of that's typically documented in a playbook. Now, playbooks can be very specific to an organization, but they can also be somewhat generalized as well. Okay. And so as an example, so I just to make, I wasn't sure who would be in the room and what your familiarity would be. So I wanted to document what a very basic playbook might look like to help level set. So from a sample, you take a piece of malware, and this piece of malware I'm calling Fuzzy Panda X, and it's for a Windows 10 a mitigation remediation strategy. So one of the first things that might be in the playbook would be for the Security Operations Center. They would open a ticket, based on an indicator of compromise that identifies this, level 2, they'll call network support, and they'll go through that process of identifying the person in network support to take it to the next thing. The network support is going to quarantine the system into a sandbox VLAN in your security zone architecture, and then it will probably go back to security operations, where they're going to go in and start talking to desktop support. They're going to do the response process. They're going to do any elevation and remediation that goes. Desktop support is going to run through a series of processes and things that would need to be due for that specific piece of malware. In a non-security mature organization that doesn't have their own playbooks, typically what the IT people will do is go out to a blog post and try and figure out, like, what do you do? And, there won't be, a lot of, there might be competing information. Some people say, oh, you just got to delete this registry key and delete this file. Other people will, no, you can't do it in that order. You've actually got to delete this process. Then you got to delete the registry key. You got to reboot in safe mode. You got to go through and delete these things and do this, whatever. So a lot of the things, like I said, would either be documented in some sort of playbook, or if you're a lower end organization that doesn't have a really high security maturity, you might be relying on the internet and blog posts. And then as it would come through, it'll finish up on the desktop support side, where they go through and they patch the OS and they patch the security software. They rerun the various scans to do various checking. And then that system would more than likely be monitored for a period of time. It'll probably be then put into a different VLAN where the computer can actually be used for normal operations, but it's highly monitored. Maybe doing full packet captures, maybe doing an IPS right in front of that machine to check for abnormal behavior. And then after a period of time, that system will be moved back into a production network. Obviously, the backout clause for any one of these line items is, if this doesn't work, then the machine is just re-imaged. Okay. And then also, depending on your appetite for risk and the type of system it is, that might be one of the things that they first do. They just format the system and re-image it. But it depends, right? There's different levels of risk, and your appetite for risk changes. So when we look at playbooks, obviously they can span multiple groups and multiple technology stacks. There's a lot of different groups that need to be involved. If you have different business units or different enclaves, the number of people that need to be involved can grow rapidly very quickly. And it's because those attacks, they can, it doesn't just come in and keep itself within one or two systems. Lateral movement is usually very easy. When I was on the other side of the fence, we used to refer to this as the escargot model of security, where things are nice and hard and crunchy on the outside, but soft and chewy on the inside. And so, threat actors can usually move very quickly laterally through the organization. And so you have a lot of people that you need to get involved. And then, they can, these attacks occur across multiple technologies, multiple technology stacks. When you do the remediation, it would be nice if the automated parts of the playbook, of the Cacao playbook, could actually be done and shipped around between technology stacks, so that different, tips or different management consoles or different tools could pick up, process the parts that they know how to process, and then report back. So how do we get there? What does this coordinated response look like? So we have, the define piece. We have the verify, that it was actually created correctly and that it works. And there's the distribution and the execute part, and then the monitoring to make sure it's done. And I'd like to pause here and just see. I know Alan, who's one of the co-authors on this, he's on the phone, and our first time using the Meet Echo stuff. So I just like to pause and see if he has any comments before I continue. Alan, if you have any.
Yeah, Alan, you'll have to get yourself in the queue if you want to talk, and then we can click you in.
Hear me?
You should be online now.
Yeah, we can hear you.
Awesome. Yeah, thanks, Brett. I think you've done an excellent job introducing the topic. I think the key part of this slide here is really talking about 5 different phases of where we are going to focus our efforts. And I think one of the first things that I think Brett has a slide later on in the deck that talks about one of the first things that we're going to focus on is really understanding what defining a playbook looks like, and that's going to be our initial focus. And then we're going to start looking at, okay, once you have a definition of that playbook, how do you then roll it out to the different technologies and across the different protocols and interfaces that need to exist. But that first bullet on this slide around definition is really our initial focus to make sure that we come up with a format of defining playbooks that is going to be truly, able to support all the different technologies that are part of a security ecosystem, as well as all the different dynamics that Brett has done a good job of introducing. Thank you.
Thanks, Alan. So one of the things, so I've been talking about this work with a lot of groups, doing a lot of PR marketing side to help drive awareness, to get people interested, to find out what the industry would look like, to make sure that we have a line of industry vendors that are willing to implement this, to deploy it, make sure that a lot of organizations that would actually make use of it are interested. And so one of the classic examples I give is a financial services response from an industry-wide response, dealing with the collaboration side of it. And so what this slide, this graphic is meant to show is how some of that could potentially work. And so, and I've talked with JP Morgan Chase, I've talked with Bank of America, I've talked with governments throughout Japan, the government entities in Japan and the UK and obviously in the US, and a lot of other enterprises. And everyone resonates with this, and it's a model that I think everyone can grok and understand. So you have once again, this is maybe for a Fuzzy Panda X type malware exploit, or pick your favorite APT name of choice. And you might have some pieces that are defined that say Apple goes through and figures out how do they mitigate this for OS X. And then Google figures out how they solve this for Android. Cisco identifies, well, if you do this on your Cisco ASA, then you can mitigate this or remediate this threat. And Microsoft may go through and figure out what they need to do for Windows 10. And it may not be Microsoft itself, it may be some other trusted enterprise or some other entity that does it. But the idea is that these various pieces could, in fact, be digitally signed, and then that signature could be included, as a plain text signature inside of this data. And then that could be rolled up and say it, I'm going to use, banks that people can understand, or at least if you're from the US, but, you have one very large bank and it goes through and says, oh, we've tested all these things. We've actually deployed it. We can guarantee, or we verify that, these at least work for this specific threat on these systems. Obviously you would need something like the CoSWID or the SWID tags or something like that in order to identify the targeting of the systems that would be affected. But that could also then turn around and be bubbled up to maybe another large bank, go from Bank of America to JP Morgan Chase. And they go in and they can verify, oh yeah, and so we're going to sign it as well. So now when this gets hooked into threat intelligence and it gets distributed out through the ISACs and ISAOs, in this case through FS-ISAC, it'll get disseminated out to all of the member units, all of the different banks and credit unions all across the fabric. And so when they have their indicators of compromise and it fires and identifies that, oh, this is a threat, then, oh, and here is a course of action or a Cacao playbook that could mitigate that threat. Now, it might not be 100% applicable to their organization, but they would be able to look at it and be able to say, oh, for these types of machines, this is what these different entities have done, and it worked for them. And, so they have some level of assurance because these larger entities have been able to verify it and they've been able to digitally sign it. So when we look at how, back to what playbooks are and kind of how they work, so we have the concept of the security knowledge that exists today, and that can come from a SOC, the analysts in a SOC, various vendors, national certs, ISACs and ISAOs, and all of that threat intelligence comes into the Security Operations Center. And a SOC, Security Operations Center, is going to go through and it's going to create these playbooks. And typically, like I said, they're going to be in either PDF form, or they're going to be printed out and put in a manual on a shelf, or they're going to be in a knowledge base article. And what we want to do is we want to get to where it's automated, or at least some parts of it or a lot of it is automated. There's always going to be some parts that will always be human process oriented, but those could be identified as manual steps. And then, when it comes time for delivery of items out of this group, if this actually gets chartered and formed here in the IETF or in some other SDO, is we want to, crawl, walk, jog, and run. So we can't boil the ocean. We can't do everything up front. And what's important is that we start to get things out to industry and get industry adopting, so that it can be rolled out in phases. And so some notional, and I'll stress this is notional, right? Because it would be up to any working group or study group or technical committee to decide. This isn't just my wish list, but some notional ideas is for the phase 1 goal would be doing the JSON data model, which would be, the multiple actions, any of the logic, the temporal logic, conditional logic, being able to version them, because you're going to need to be able to collaboratively work on them. Any targeting, the specification of using SWID tags or COSWID or I think SCAP and all these other little things that might be available. And then being able to do syntax verification to make sure that these are, formed and structured in a way that is interoperable. A stretch goal, in my opinion, would be able to do partial automation, doing digital signatures, being able to do distribution, protocols so that you could communicate either between entities or potentially between technology stacks, or maybe even, the connections off to some devices, actuators where they could process it. And then a phase 2 and phase 3 goal, phase 2 would be, like a longer term, maybe a second release, doing some of the more automated action pieces, execution verification. Basically, what is the resource that you need to send to the device, and then what is the resource that needs to come back to do the verification. And then, phase 3, longer term goal would be like full automation. So.
Yeah. So I think what we'd like to do right now is, I think Brett's given a kind of pretty good overview of kind of the problem space, and like to have some discussion now in the room, just make sure people understand, because some people are going to be very familiar with this space, and for some people it's going to be something that they're not. So if people are, please feel free to come to the mic and ask questions or provide input. Oh, sorry. Yeah. Yeah. Is it not going at all?
There are no speakers in the back.
Okay, so when we look at the orange. So yeah, thank you, Brett, for making this presentation. So I have some clarification question about what you have presented so far. The first question with regard to the creation of the playbook itself. Because for me, this is just this single task is really, I would say, tough and it's really difficult to be done in a generic manner and for all the attacks. So do you think that this is really a key, I would say, expected output from this work, or we assume that the playbook is done somewhere, handled somewhere, and then the problem is how can I pass it through something which is really standardized in terms of the communication interfaces between involved parties? This is my first question. The second one is that do you assume that all this work, because what you have presented so far is really, for me, is really, I would say, one single network provider there, and which is dealing with some, I would say, sources, vendors, and so on, this kind of stuff. I quite don't see the need for, I would say, a standardized interface for that one, because you can receive, for whatever interface, from a server, just you connect a server, you receive your file, and then you push it somewhere, you run your machinery somewhere, and then you can correlate the various playbook, and you generate your own one in your domain. So do you exclude I would say, the collaboration between multiple network providers? Because for me, this is something which is really missing today. We are confronting I would say, distributed attacks, and the attack starts everywhere from the world, and everyone in his own network is trying to dig into the problem and try to look how can I fix this problem. and we are repeating the same story, and some are going to forums looking for, I would say, hints, suggestions for mitigation, and so on. So if we, I would say, if we adopt the same strategy for these distributed attacks to have, I would say, distributed mitigation, and if we want to distribute distributed mitigation, we have to open the collaboration between the multiple involved parties that are network providers. So I would like to see this interface to have something which is more collaborative in terms of sharing, just to say that's, I have this kind of attacks, this is what I'm doing, just take it as information. You don't take it as a fact. You can try it in your context if you have this kind of problem, and so on. So we are just sharing the learning and the lessons from the problems we are seeing. So clarify the I would say the specific context, and justify why we need to have something which is more collaborative between network providers.
Thank you. Thank you for the question. So in looking at this, at some level, you have to have the thing that you are going to be able to exchange and to be able to share. And obviously, I think this structured object will evolve over time, but we need to have the basic foundational pieces in the beginning in order for that to be shared and then to be able to be actioned on. It needs to be able to be processed and be able to be consumed in a machine processable form. We have a lot of experience with this in the threat intelligence world, and we understand kind of how these things work across ISACs and ISAOs, and so we're trying to build on that model. And I'll pause for Alan, my co-author, to try and respond as well.
I think you're live, Alan.
Yeah, thank you. So one additional thing that I would add to the answer that Brett gave was that if some people may not be familiar, but there's a standard being developed by Oasis called OpenC2. That is a basic mechanism to respond to threats, but it's focused on individual actions across different security infrastructure. That group has specifically said that they do not want to tackle how you connect all of those commands together in a sequence or in a temporal logic. So what we feel is that there is other efforts trying to standardize and normalize languages to be able to respond to threats, such as OpenC2, as well as sticks for intelligence aspects. And what we're looking to do is kind of build a playbook that kind of wraps some of those things together so that you can start to chain them together in a more coordinated fashion. So we are not going to be necessarily relying or defining individual protocols or commands to execute, like, for example, block actions or response to an antivirus, etc. We'll be chaining that together.
Ashu Singh. So thanks, Brett. This is a very important topic, I believe. And I think this, having an enterprise background myself, I think this is very relevant, especially with transition to cloud and enterprises having less and less control over what gets deployed and how things are deployed in the cloud. So I just wanted to ask you, how do you envision this in the cloud deployment, and how do you think this fits in the cloud story, because that seems to be the way forward.
Thanks for the question. I think this is very applicable for a cloud strategy as well, because it would just be a series of actions and commands that would be pertinent to mitigation, remediation, or prevention of some threat. And I think you could argue that actually in a cloud deployment, it becomes easier from a targeting standpoint or the identification of the system because there's more commonality. You're going to have less variability like you would in an enterprise. So I think the cloud deployment model works just as well. And being able to group all of these things together and then to be able to do the collaboration and have organizations inside of a trust group be able to share these playbooks back and forth and be able to iterate on them and improve them, I think is going to be very valuable. I know some governments, like Australia, for example, they set up trust groups specifically for identified threat. And so they will pull in people across the nation, and they will bring them into a trust group, and then they share information. But it's all over Slack, or it's over Skype or things like that. And it would be nice if these things were done in a machine parsable way, so that tooling could process it and action on it.
Yang from Huawei. My question is, in the phase 1, is it all this shared playbook, all the action will be performed manually by human?
I think initially, if I was to give realistic expectations from a vendor deployment model, is initially that they will be collaborated on and documented in a machine parsable form, but they'll still probably be human actioned. Some of them may have the actual commands that you would use on a device, say like on a Palo Alto firewall. Here is the CLI command that you would copy and paste. And then over time, the vendors will begin to adopt this and be able to process these commands. And then you'll start to see, like if I'm not going to talk about my own company, but we could potentially consume this on our ICDX infrastructure and process this across our fabric. And I know other vendors could do this as well. So, but the phase 1, when we look at this, like how do we gain vendor adoption and how do we gain people to start using this? And one of the first things that we look at from experience with threat intelligence is you need to have the data model and you need to have the structured form, so that tools like a TIP or something like that could render it, they could process it, they could link it into a case management system, they could be able to build automatic, messaging, back and forth between teams and stuff like that. And so it's like, that's the first nut that we need to get standardized. And then my hope is, and like what was it Mohammed from Orange has mentioned, that, getting this to be able to collaborate between, the various groups, and in his case, telcos, which we're very partial to, and we really want to help solve that. It's just, maybe we look at it that, where we need to start is, so.
Okay.
But thanks for the question. Do you have another follow-up?
Yeah.
Okay.
Second one is, are we going to define a set of atomic commands to make it more easier to collaboration?
I think where possible, it would be great if we could use other standards that exist either here or elsewhere to define those atomic commands, whether they're like a DOTS thing or a I2NSF, or whether it's one of the other pieces, NetConf or OpenC2 on the other side. But where those solutions don't have an option, we can either request that they add it, and if they say no, then we could add it here. I think some things we'll probably have to do, like the manual pieces, we'll have to define what that part of the ontology actually looks like. But because most of the other ones don't do that. But I mean, there's going to be a little bit of work that we need to identify. But I think where we can leverage other technologies, I think that would be great.
Okay, thank you.
Hi there, this is Stephen Banghart, channeling Nabil Bitar on Jabber. How would this be different or related to what is implemented by SOAR, S-O-A-R, systems? And Jody Verma already responded and mentioned that they could render and execute the distributed Cacao playbooks for mitigating and remediating the threat. Figured I'd give you a chance to follow up if you have any other answers to that, Brett.
I would respond very similar to the way Jody did. So.
I'm Watson Lott. I just have a few clarifications. So when you talk about a intrusion set, is that the sort of set of all the techniques one particular group has, or is it just sort of in general anything that's out there?
So so it's a set of techniques and tooling and capabilities that exist and they're tracked as these atomic things, and threat actor individuals come into these and use them and go away from them over time. It is a term that is a little bit hard to grok at first, and it is definitely a term that's very common across the IC. But that's how these toolkits and these tool chains and whatever are tracked. And so that you can begin to understand, and this isn't for this group, but you can begin to understand the capabilities and techniques of a threat actor group by how quickly their intrusion set changes. So if you have 5,000 servers in your toolkit that are processing for data exfiltration, and that changes from one data center to another data center every week, then the number of people you have involved is very large, because that takes a lot of work. So, but if things are pretty static, then you might have a very smaller crime syndicate.
My other scoping question is something like patching within scope for this, like identify vulnerable versions and say you should update these versions. Is that something we need to include as well?
I think you would at least call out, the potential of even just a string of, patch to current version, or Microsoft releases knowledge base article 4321 that, mitigates this threat. And I'll pause for Alan to answer.
Yeah, just on that point about patching, one of the most common things that people do is exploit vulnerabilities that are on public infrastructure after they've discovered that that is a vulnerable system. So one of the things that people want to do is be able to do that scanning or detection of vulnerabilities themselves, and then automatically run playbooks that patch those systems so that those systems are no longer vulnerable. So it's not even responding to an attack; it's actually responding to defensive behavior that you would take place on your own network, that scan, you define things that are vulnerable, and then automatically patch it. That would be another use and cause of why you would want to run a playbook.
Yeah, and a follow on that would be maybe like a SANS top 20, a preventative, or CIS top 20, preventative, scenarios. They may not be specific to target specific systems, but they would be generalized things that could be distributed, and then and like I said, in a trust group, they could be collaborated on, and they could be worked on, and refined and added to. So, Ben.
Ben Kaduk, so you had mentioned being able to collaboratively work on and iteratively update these sorts of things. Do you think it's important to have sort of technical measures to foster that in terms of the versioning structure, or are we not going to worry about that too much in the actual technical details and leave that to a social?
Thanks for the question. I did call that out as a line item that would need to be in the, the phase 1 release, in the crawl phase, that you need to be able to version these objects. Obviously, I have a set of requirements, or, from my perspective, in the follow-on pieces of the slides that you can see. And obviously, one of them also is a unique identifier, like a UUID v4, because it needs to be able to be linked into a graph for the rest of threat intelligence, so that you can make use of it. It needs to be able to be versioned, so you need a version number or some sort of identifier that can be versioned, because as they go between different groups and as people are adding stuff, you need to be able to understand, do you have the current version or not?
Yeah, I guess it's sort of a question of, is it a single global version number that has to stay synchronized across everyone, or is it a little bit fuzzier?
I think that would be a decision for the group. One way that I
don't want to get too off into the
yeah,
weeds.
I don't want to get into the weeds, but one thing that could potentially be used is just a timestamp with microsecond precision,
Sure.
An ISO, or an RFC 3339 timestamp with microsecond precision is a great way to do versioning.
So from the chair, can we kind of stick hopefully a little bit more to problem understanding? I mean, so there's a whole other part of the presentation about requirements and solution space. So if you can, what we're trying to get to at this point is to make sure that everybody has a chance to make sure they understand the problem definition, and then we'll progress past that.
Hi, Brett. Roman Danelius. So I think I understood the vision, but I'm trying to understand what that means relative to standards action with the phases. So I didn't exactly track it. So if you could help me clarify. So I get the binder issue. We're passing around kind of binders that are PDFs or in wikis. And it seems like there's also the other half was this idea of, well, now that I have an automated version of, or a machine readable version of the binder, I want to task systems to act on that. So are we, where's the work? Is the idea that we want to solve the binder problem, or the tasking once we have the machine readable binder?
So in my personal perspective, obviously this would be a working group decision, or decision by whatever group allows us to do this. But the first thing that needs to be done is the data model needs to be defined so that there's a structured way that you can document them. And so if you're sharing these over HTTPS, or even if you're sharing them over email, they could then turn around and be processed by a machine. The goal being that tip vendors and other management consoles in the network or orchestration devices like a Phantom, Demisto, Swimlane, something like that, could then turn around and consume this and be able to render something to the user or to the SOC in a structured way. So obviously we have to crawl, walk, jog, run. But then the follow-on phases would be to enable vendors and solutions to be able to pull out the atomic actions and be able to, operate on them in somewhat, of an automated way.
So that piece about the vendors operating them, is that standards activity you're suggesting for the IETF, or are you only saying the making the binders machine readable is the standards activity?
I think that the most important thing is to be able to get a structured ontology for this data model so that vendors can implement to it. So we need to make sure that when you define the individualized actions and the conditional logic and temporal logic that binds those actions together, that they would be able to be consumed. So hypothetically, an action might say manual and do this, or phone call and hook into your Cisco call manager and wake CIO out of bed. Or another one might be netconf and do this command to configure your switch, or I2NSF, do this. And so there's going to be some things that we're going to need to pull in to enable people to automate. So I'm not quite sure how to answer your question. I think I understand where you're trying to get. But I think the first thing that we need to do is the data model, the ontology for what this would be. But I'm sorry, I'm not quite sure how to answer your question.
Hi, Michael Richardson. So I have a bit of a scope question as well. And I guess I was going to ask a question about, were these playbooks procedural or declarative? And maybe I realized that was too much of a solutions-based question, but it actually does go to my scope question, which is the point here to mitigate an attack? Is it to identify an attack, in which case we've done some work in mile and inch and other things like that? Or is the goal to document a potential fix for the intrusion or the issue? And because they seem to be kind of mixed together, like, you said, do some I2NSF to change some things, I guess, protected device. Then people are talking about, oh, there's this magic patch level that you should be at, which would be fixing things. And I'm confused by what seems to be a mishmash of reactions and actions and things like that.
Great, thank you for the question. So the purpose is to be able to document what is in playbooks and runbooks today. So it's not about the identification of the threat. That is handled through various means, whether they're here in the MILE, SACM, groups here, or whether they're in the STIX community, which is outside of IETF, or through something else, right? So indicators of compromise, the industry knows how to do that. There is structured ontologies for identifying and sharing that information. So that we're definitely not doing that. What we want to be able to do is document, the process, the procedures that you would use to mitigate, remediate, or prevent a threat. And those initially will probably be very human-oriented, human task commands, but in a structured ontology. But over time, they will be automated, and they will be call-outs either to a native API, to a CLI command, or to one of the other solutions, like I said, like I2NSF or netconf or OpenC2 or one of those sort of things. So this is what playbooks are. This is how they're done today. Mm-hmm. They're just in PDF form or in paper form on a shelf. And so,
but it's a stretch to my credit. I'm a bit incredulous that these very specific commands don't require significant localization across organizations, right?
Oh, they do.
That's where I'm skeptical about the automation part. So I get the let's sign these things. This was what worked for me. I get that, and I like the picture with the boxes, and that was really cool. I'm like, okay, looks like an application of S-MIME to me, right? That level. But And maybe if we deploy that between all those people, the world will be a better place anyway. But I'm having difficulty because of the procedural nature of what sounds like it's in the playbooks, that well, it could maybe automatable in one organization. I'm skeptical about the how that can be automatically translated elsewhere, and that's where I'm having a lot of problems with the thing. And I had another thing which I wanted to ask, but I'm actually dealing with the question of how do we bring IoT devices that are identified as bad? How do we recognize that they are now good, that they have been through a playbook of some kind? So that's where my interest comes from, but I don't think that that we're ready to discuss that question yet here. So
yeah, thank you for the question. I'll pause for Alan to take a first stab at answering, and then I will try and answer.
Yeah, there was several questions there. If I go back to the original question, which I think you were saying about, is it mitigation or is it detection? One of the things that is not very black and white is exactly whether something is a threat or not. And so oftentimes the ability to copy traffic, redirect traffic so that you can do closer inspection. Your behavioral analytics, for example, may identify something suspicious, but you're not exactly certain what it is. And so the ability to have automated playbooks so that you can instruct the network and potentially endpoints to do things, to be able to start looking at things more closely, is an aspect of investigation and an analysis that would then potentially determine this is absolutely concrete a threat, and then you would go into the phase of mitigation. So it is not just, oh, you've absolutely detected something as a threat. It is also being able to investigate to be able to say that it's a threat for certain. So that's the first part. I think the second part of your question was about, well, how do you make this reusable across different customer specific environments? One of the things that we've defined in the requirements is the specific ability to modularize the playbooks so that you can construct not just signed aspects, but also modular aspects. So you could imagine little modular functions that can then be constructed to be able to do very specific things that ultimately are shareable. So it's almost like sharing open source functions that do very small things that can then be constructed into larger playbooks. That is absolutely a goal, so that that customization for a specific enterprise environment can be more easily made available to people. So the idea that this is one huge monolithic thing that somebody has to figure out how to make customized to their environment is going to not be a goal. Thank you.
Let me just take one quick stab at it too. So another way that I explain this when I talk about this with industry is, hypothetically, I could see an entire ecosystem of startup companies getting created that produce playbooks for identified threat for targeting specific systems. So, Windows 10, Service Pack 3, Service Pack 4, Service Pack 5. Maybe there's a cloud service, you get an indicator of compromise for some piece of malware, you have the hash, like a virus total. You could go up and you could provide that hash and then say what type of operating system, maybe the SWID tag, and then you can download a playbook and it would show you who had signed it, who had verified it, and give you the commands in a structured form. Obviously, we have to crawl before we can walk, jog, and run. And so we need to be able to get to where we can do what we do today in playbooks, but do those in a structured way. Dave?
Dave Waltmeyer. So I thought I was clear on what the problem was, what the scope of this was initially, and now I'm a little confused. Part of it is when I hear things like ontology, my eyes start to to glaze over. But just to go back to what Roman was saying, so he asked, is the focus of this, at least is the initial focus of this effort, on the binder, making a machine readable, structured representation of the binder, or is it on the atomic actions? And what I'm hearing, I think, is that this effort wants to put some framing, some machine-readable framing around that PDF binder in a way that becomes machine processable, which deals with some of the conditional logic, some of the tracking as information is passed between organizations, maybe even the integrity of that document as it's being passed around, that you were going to defer on the action piece, the atomic action piece, to leverage existing standards, at least initially, maybe fill gaps long term there. Is that the right view of this?
That's 100% my view. So you said it. You answered his question perfectly for me.
Okay, thank you.
Rüdiger Volk, Deutsche Telekom. In multiple ways, I feel in this session very touristy.
Well, I'm glad you're here because
yeah, well, okay. No,
I love Deutschland.
Yeah, well, okay. Kind of touristy can mean in IETF universe. Well, okay. You can also say cross-area visitors or something. I'm working at Deutsche Telekom essentially as a routing architect. And so I'm dealing with the threat, with the fairly general threat of well, okay, what's happening in the routing system? And my observation when talking with security folks is that it looks that there seems to be a fairly large gap between what the expertise and the focus of the typical security guys is. And yes, it's obvious that dealing with the end systems is very interesting and most important. On the other hand, a kind of understanding what the infrastructure threats are is something that is kind of a different world. And sometimes or most of the time, I think not integrated very well. And integration for all of the security functions obviously is something that you would want to have, but it seems in some places to be hard to do. And I have been watching the presentation, and essentially everything that I heard was telling me, well, okay, kind of the place where actually to integrate and cover the infrastructure stuff, where, well, okay, atomic actions about, well, okay, what do I do about root hijack? Yeah, kind of, I would like to have that.
I completely 100% agree with you.
And kind of what I'm seeing is that gap, I think, is not often discussed explicitly, like I'm trying to do right now. And as activity like this kicks off, I see that at least as an opportunity to remind that there is this kind of gap, and one might, with a new activity, try to at least not extend it more and make a lot of progress in some parts and leave behind the infrastructure stuff. I don't have a lot of things to help. I'm working on the routing security, but kind of yes, if I see something like a tool set that you are for handling stuff and processes, kind of yes, I would like to see something where I can tell my SOC that, hey, you usually don't know about the routing, and there is a possibility to integrate.
Exactly.
Please have an explicit look into that direction. Again, I feel touristy here. My day job is demanding enough.
No, I think thank you for the question, and thank you for standing to the mic. I do talk about that when I mention this, in other contexts, but I usually always start with the machine and the malware example, simply because most people can relate to that. But I could very well see, you have an indicator of compromise that identifies, BGP hijacking, or maybe domain fronting, or something else, some sort of router compromise. Your ISIS, protocol got compromised. Your EIGRP, protocol is doing something weird, and what are the things for that, and that you could, I would hope that our our design of the data model would easily allow you to document that a solution for that. You know, I come from your side of the fence, so I'm very familiar with, you know, with the network side of it. So I just don't usually lead off with that because most people in the room don't usually understand. And so I'm trying to phrase it in context of things that hopefully people can understand. So if you come from a SOC, then you understand what these playbooks are. But if you don't come from a SOC, then it's sometimes a little confusing.
Roman Janelu. So yeah, good with the interchange with Dave, and that helped me understand. So machine-readable binders whose atomic actions are coming from someplace else, we're providing the ability to create the more complicated version of those actions. And then kind of the follow-up is, and then we want to provide tooling to exchange that machine-readable binder in an enterprise across administrative domains. Can you talk a little bit about what you think we need to do with that machine readable? Which is that part of the problem?
Very great question, Roman. So I think, you know, the sharing between organizations, I think, you know, could be done in a lot of the same ways that threat intelligence is done through ISACs and ISAOs, you know, defining some, you know, mandatory to implement, you know, solution like a Rolly from here or some other solution. Or just HTTPS, but having the structured binding, right, the data model is important. Longer term, you're going to want to be able to integrate this in a consumable way with various, you know, orchestration tools. Like I said, you know, not to call out vendors specifically, but in case you're familiar with them, like a Phantom or Demisto or Swimlane or something like that, with various tip solutions like a Looking Glass or an Eclectic IQ or other tools like that. But initially, you have to have a data model. So
the chairs want to get chairs want to get a sense of the room. How many people? Can we get a show of hands? How many people think they really kind of understand the problem and you know the thing that Brett's proposing as the issue that needs to be worked? That's not so bad. How many people?
How many was that for those? Or what percentage of the room?
Most.
Okay.
How many don't understand what? That's the next question. We haven't gotten there, but I want to do the you know, contrapositive of this. How many people do not understand the problem? Yeah. Few.
Do you want to come to the mic?
Okay, this is Paul Jung from SKKU. So looks like your problem looks like the Pansy, but as I understand that the Oasis, the standard body, they already have sticks and also the protocol taxi. So I'm wondering what is the main difference between your proposed one and the sticks? So they already providing the threat, information representation looks very good. So yeah, could you clarify differences from them? Yeah.
Yes, and I can answer it really briefly here, and we can talk offline. I am an editor on Styx, an author there, so I understand that spec very well. So Styx is solving a slightly different part of the problem. They're focusing on doing the cyber threat intelligence side of it, identifying the threat actors, their campaigns, the indicators of compromise, the malware, the pieces like that, and a very loose binding to a course of action. And if you look at what Styx is doing for course of action, we've already put in a hook to call out to link to a Cacao playbook. So because Styx, the Styx community does not have the expertise nor the desire to work on the playbook side because it's outside of the scope of their charter. OpenC2, it's also out of the scope of their charter because they're dealing with the atomic actions, the individualized, you know, command that would be sent to an actuator. And so what we need is this higher level thing that can be shared across the internet, that can be shared between business units, enclaves, trust groups, that allows collaborations of these larger things that are done today. So. Okay. But if you have specific detailed things, I can talk for hours about Styx.
So the other question is that you are talking about the playbook. So could you define clearly? So I'm actually cannot reach your point. What is the playbook looks like? So do you have some example for that? Yeah.
So I don't know if you were in the room when I went through this, but a playbook is a collection of processes that an organization uses to mitigate, remediate, or prevent a threat. They're typically, today, they can be very elaborate, but they're usually written down in a knowledge base article or in a PDF document, or in some organizations, they're in a binder on a shelf. And that you pull that binder off, and then you go through and you start processing through the playbook. So an example, and this is once again, and I apologize for my friend at Deutsche Telekom, but this is not the network side of it, or the telco side of it. This is the system, endpoint malware side, is to give an example. So, your security operations center is going to go through and it's going to do various things. It's going to open up a ticket. You're going to probably have escalation paths. You're going to call the network operations team, and this person, if they don't answer in 20 minutes, you're going to call this person, and then you're going to call, further down the line. It'll eventually go to the network support team. They're going to quarantine it. It's going to go back to security operations after the machine has been quarantined, to go out to desktop support for them to do mitigation, remediation, processing. Desktop support is going to run a series of commands because they know the malware, because they have an indicator of compromise that identified exactly what thing it is. And if it's stage 1 delivery or stage 2, or whether it was lateral movement, or whether it was the rat, the remote access Trojan, or whatever piece in the, like the Lockheed Martin kill chain. And then for this specific one, for Fuzzy Panda X, here's an example of some things that would need to be done from the desktop engineering, desktop support side of it. And they're going to go through and they're going to process all of these steps. And then in the playbook, it would then go back to network support, where they're going to monitor the machine to make sure, did it actually get cleaned up? After some other period of time, it would be moved out of the sandbox VLAN and into a semi-production VLAN, where it's maybe more restricted, but it still can do basic things, and it might be there for, say, 24 hours. And then eventually, if it shows no more sign of compromise, it'll be moved back to production. Obviously, a classic point on any one of these things is if there's a problem, or something doesn't work, the conditional logic is to re-image the machine. So, and so this is kind of what a playbook would look like. This is very simple, but I wanted to give something that everybody could kind of understand. A lot of these have, very elaborate things. You might imagine if it's an internet-facing web application, you might need to involve PR, because you might need to, identify the call center, because you're going to have to contact the press. You may have mandatory reporting. You may have GDPR issues that are involved. And so playbooks can get elaborate pretty quickly. But once you develop the basic structure in a data model, then it's just basically rinsing and repeating. You're just adding more of these down the thing. And so we want to be able to document these in a machine way that you could then collaborate on, and also be able to share.
Okay, I think it is pretty cool. Also, Linda and Yao, they are working for I2NSF. Also, I am working for I2NSF. I2NSF is, I think, is a very good platform to provide what you are proposing, because I2NSF consisting of a security controller, the network security functions, such as you are talking about some security, some application or system. So we are having some monitoring, some interfaces to monitor what they are doing, something like that. So I think you take advantage of I2NSF work. Okay.
Yeah, and I mentioned that several times in the slides, is that I envision us making use of I2NSF, NetComp, other pieces that are either done here in the IETF or that are done in other SDOs, because they have solutions, and we should not reinvent the wheel. Okay. And we also don't want to boil the ocean.
Yeah. Okay. Thank you. Yeah.
All right, we're going to go into the second question for the chairs, which is, can we get a show of hands? How many people think this is an appropriate problem or suitable problem for the IETF to tackle?
I have a question before that. I just didn't think it
Sorry.
fit in the last set of
Go ahead.
of what you were looking for. Okay.
No, I was
A few
I tend to
efforts.
talk long, sorry. So.
A few efforts have already looked at aspects of this. There were some that were mentioned already. IODEF has the ability to nest and order responses, and RID had the signature aspect well-defined, and nesting of signatures and multi-hop authentication and policy aspects. I haven't seen a good analysis of the overlap of each of these and the barriers to adoption that each of those have faced. So if you're building on Stix and Taxi, they're not well deployed right now. OpenC2, what's the adoption rate? How will this differ from those and actually work towards something that would be adopted? And if you have good answers around that, then I'm all for it. We don't have to say like, I'm fine with, my stuff is old, so IODEF and RID, that's at least the RID piece it's pretty old, so I'm sure it's not perfect. But I'd like to see what's the big difference. And from the Karis workshop, one of the things that came out of it when we looked at some of the efforts that have failed, because we were trying to analyze what failed in this space, what went forward and why, was looking at what do people actually want to exchange, and it's small. So, and maybe the models of sharing, I think, have been a problem. So I'd like to see how, what your thoughts are on why we need to do this and how it will differ from past efforts. And I'd really like a great analysis on that.
Thank you. Thanks for the question. So on the threat intelligence piece, which I'm very familiar with, so let me tackle that one first. Standards take a while to get adopted. I know on the Stix and Taxi piece, it is getting adopted pretty quickly at this point. Most vendors are implementing it. IBM's new solution that they have just released at RSA is all back-ended off of Stix and Taxi. I spoke about Cacao at the first conference last week in London, and nearly everybody there is using tips that are using Stix and Taxi. So that part
Interoperably?
Interoperably, yes, because they're sharing the information through their ISAC and ISAOs. So things, but it's still probably 3 years before that actually goes like full mainstream. OpenC2 is definitely much more nascent. It's still trying to get legs under it, and I would give it, maybe I shouldn't say this over the mic, it's probably recorded, but it's just very nascent. It's up and coming, and it's going along. I think a lot of the work that you've done personally is brilliant. I would hope that a lot of that could either be reused or incorporated or something like that, going forward. But the purpose of this is really about understanding how we can document, the playbooks. And I know I've gone through the IODEF stuff, and I know Stix really well. And yes, I could force this into both of those, but they're not really designed for that piece. So
Yeah, and I'd also like to see, where those failed and how yours will improve as this is developed further, because that's important, right?
Thank you. Thanks for your comment.
Roman, Daniel, quickly, and this is more for the chairs. If we're going to ask the question, is this suitable problem for the ITF? We actually presented a very broad vision. Should we be answering that question with a more narrow version of something? Because I heard different phases. So are we talking about all the phases, one of the phases?
Go ahead, Jess.
Okay, Jessica Fitzgerald, McKay, NSA. I wanted to point out that maybe this vision, maybe this is in line with what Roman was saying, actually. Maybe this vision could be better captured as starting with a data model that could be incorporated into things like Stix and Taxi and could carry things like OpenC2 in order to sort of, box it appropriately so people aren't as concerned about the overlap. I see an absolute need for something like this, but I think when we start talking about maybe the distribution protocols, that's where people are starting to get wrapped around an axle of what is this, how is this different? Maybe scoping it down would help that.
Yeah, and I apologize for any, any confusion that I would give in presenting of the material, and kind of, I only have an hour and a half to kind of talk through it. So I'm trying to get everybody up to at least the base understanding, but I would agree with you that that is, the objective, the first and primary goal is to get that basic data model done. And maybe that's where we stop, right? And then we leave it to NIST or other standards bodies to do further work on it. I don't know, but yeah, I tried to put some of these things in here to help people understand like what this solution could look like longer term, especially when you look at how do we as an industry move the needle to improve cyber defense and enable more rapid response. So,
Hi, Dan Amigo. So I'm hearing about data model, but I'm just wondering how many data model we would need to have the core of this work to be workable. Is it 1, 2, or
it's 1?
Perfect.
Yeah, just one data model. So you identify how you wrap atomic actions, and then how those actions, obviously you have to have basic targeting and versioning in those atomic actions, and then what is the conditional temporal logic pieces that would bind those together to form a more higher level structured playbook. Thank you.
Alyssa Cooper, you may have just answered my question then, but so that's true whether there's a human being executing this thing or whether there's a machine executing it?
That is correct. So yeah, so in playbooks today, we document the commands, and some of them may be process-based, some of them may be human-based, some of them may be run this command on your firewall, and they'll actually put in the CLI command from your Cisco ASA, your Palo Alto firewall, or Fortinet, or whatever you have. And an operator, in the NOC or in SOC, depending on who has access rights to it, would just copy and paste that in. So the idea being that you would have a tool like an orchestration device, your hand wavy around which one you like, the flavor of the week, that could consume this playbook, display it, and then some of them, depending on your appetite for risk and what your procedures are in your organization, some of them may be processed automatically, some of them may be bubbled up to a human to say, click here if you want to process this, some of them may just be completely manual. So, but it's the idea so that when organizations produce these, they can collaborate across the trust group, which they do today, so that we're not envisioning like something that might happen in the future. These trust groups do this today, and they share the playbook information across side channels, usually over Skype or Slack or something like that. And then somebody will come along and they'll post various blog post entries about it. And so,
But the automation does not happen today.
Automation does not happen today
Okay,
because there is no
yeah.
structured way to do it.
Okay, thank you.
And that's what we're trying to get to, is some level of automation. Yes, automation has to come in phases. And so we have to start, have to learn to crawl first. And then hopefully over time, over time, I mean over the 5, 7, 10-year event horizon, we can get to where a SOC can mostly operate at automation at some level of risk profile.
So I just wanted to add that there are enterprises that do have automation of playbooks. So I'm not sure when you said, yeah, people don't automate today. I would disagree with that. There are definitely enterprises and organizations that do have automation of playbooks.
Yeah, and I can comment on that. I can't name which one, but we've worked with a large group that has fully implemented their own proprietary internal solution to this and is very excited about this, because then it would add interoperability across technology stacks and across organizations, but they've fully automated their playbooks. So this is being done. So.
Okay, thanks. I mean, so this is like way outside my area, so I might be, just really ill-informed to my naive mind. It's very hard to understand how you can possibly capture all of those things and also have them mixed together off of the basis of a single data model and a single set of protocols that will be executing off of individual pieces of data that are exchanged in one of these playbooks. I think you explained it fully. I'm just saying that for me, it's hard to grok.
Yeah, you can go and look at any of the demos from, current providers of orchestration, and you can get a feel for what they can do today. So at least that would be the commercially available solutions. But in your role at Cisco as a fellow, I'm sure you can talk to some of the same people that I talk to.
So I actually favor the fact that we see automation as a long term and not a short term.
Yeah.
Let's make the themes.
Well, it's realistic, right? We have experience in doing this and working with, especially on the threat intelligence side, and what can be automated and what needs to be semi-manual, and we have to crawl before we can walk, jog, and run.
Hi, Brian Trammell, wearing no hats, but as a trainee site reliability engineer. And I think Chris is typing something up that answers my question, but I'm going to ask it anyway. So we're talking about a scope about a playbook data model for incident handling,
or prevention.
A lot of these things seem really general to incident handling without so I mean, there are cyber incidents, there are availability incidents, there are somebody pushed some code and something went down. I mean, this looks like a way to automate SRE, and I actually kind of like automating SRE because that's the whole point of SRE. And I'm kind of wondering, how do we keep this scope in this working group from going that large? Because that seems like now we've boiled all the oceans on this planet, and now we're going to put oceans back on Mars and boil them too. I'm really interested in boiling the oceans on Mars, right? But so I'm really concerned and would like to see, and I think, Chris, you're typing this up right now, so would like to see how we restrict this so that it is only mostly impractical to do as opposed to entirely impractical to do. And I'm not really sure how to do that because the temptation will be, and a loss of availability due to a security incident is not that much different than a loss of availability due to something else failed, right? So there'll be a lot of temptation to scope creep this. And I'm going to be, if this happens, I'm going to be one of the people tempted to scope creep it. So I'm really interested in making sure that we have a way to at least draw the box. And I think it's by saying, oh, we're going to talk about RAID and taxi. We're going to talk about all these things that are in the space that are, it's not the orchestration system that's going to have the restriction of scope. It's all of the things that the orchestration system is built on top of that have these assumptions about cyber in them.
Yeah, like I said earlier
Okay.
on, this is not about
Okay.
anything in the physical security space, but there's other things that we need to scope out very clearly, so that we're targeting a very
You
specific.
say it's not in the physical security space, so I can run you off your playbook if I just decide to pop a lock in a data center. That's cool.
So security, physical security has their own set of playbooks, but the intent is not to document them in this.
Yep. I get it, but
so
yeah. Let me think about this a little bit more. But I would. So let me just make this caution. Still no hats. Make sure that we scope this in a way that it won't do that.
Oh, so then you get to Michael again. So now you're adding your question back at the bottom, which I really wanted to understand. So maybe I can ask everyone in the room, is anyone else familiar with the concept of Jupyter notebooks? Okay, so, all right. So I haven't used them much, but for people who haven't used them, they're essentially, and Brian, you'll correct me if I'm really way off, they're essentially markdown documents with Python or R or other code that you can do stuff, plus the results come back and something, edits them and can run the code. But you have English text about things followed by executable stuff and the results coming back in there. And that maybe is good enough for the thing. What I'm hearing is that playbooks need to be something like that. But then I hear things about all these protocols and other things in data models. And I think, wow, if it was just something like a Jupyter notebook, then I think that all we need to do is find a way to multiply sign parts of documents that don't always overlap, such that we can have those nice boxes on the other side. That would be the scope of the world of the solution to me. And I would say, well, that sounds like an XML Oasis kind of thing, and it's not our problem. And then I hear about data models and other stuff, and then I can't actually imagine what the solution is, and so I find it very difficult to know if it's suitable to the IETF. And so that's where I am in trying to understand what is it you're going to do that's giving me difficulty that makes it suitable to the IETF.
Dave Waltermeyer. So can I comment on what's up on the screen? Perfect.
Absolutely.
So I think the one thing I'm bristling at is executed by humans. Because I think part of what I heard we're trying to solve here is to do better than the current PDF model, which is really designed to be executed by humans. I think what we want is that could be executed by machines with the interaction of humans.
That is correct. Because you need to be able to consume these and render them by machines, and then certain parts of it, depending on your risk profile, would be bubbled to a human.
Right. And then to speak a little bit to what Alyssa was talking about, or maybe it was Michael, I think there is some scope creep risk when we start talking about how you contextualize when a command should be run or not. I think as far as tightening a charter around this, we're probably going to have to try to put some safeguards in to keep that scope small, because when we start dealing with all of the contextual information in the enterprise and some of the really complex conditional logic that could potentially exist here, that starts to get to be a really hard problem. So we need to find a way, if we're going to move forward with this, to scope that to a reasonable level, maybe make it extendable in a way that more advanced capabilities could be added.
Hey, Mike Rose at DHS. I personally been liking everything I hear so far. DHS has openly been supportive of playbooks for a long time now. We've collaborated with NSA in the past as well, working towards this playbooks. I agree, scope creep is definitely a problem. The charter needs to make sure that we're not going to get out of hand. Focusing on the specific points that we've been talking about today is definitely important, rather than running amok and trying to solve everyone's problems. But I'm not worried about it. I think the end game of where you're looking at is where it's going to be, and I hope we can actually automate this moving forward. But I'm glad we're starting at the crawl phase at the moment. So
thank you.
Elliot Lear, I agree. I'm not too worried about the scope creep, but what I would like to see is a little bit better diagramming, if you will, of the actors involved as you're going forward. And also the trust relationships that are expected, and how those are intended to be implemented as you move forward.
Great, thank you. Yeah, I do have a lot more content. We spent a year and a half on this. We have a good 80 some odd pages of stuff, but we have some groups that have been contributing that can't contribute that work until there's an official working group, technical committee, study group, something that locks in IPR, because their OGC says we can't submit it anywhere publicly until there is something there. So unfortunately, we have a lot of content that we can't share yet because we don't have something either in this SDO or another SDO that locks in that IPR.
Sanjay Mishra, Verizon. Thanks, Brett, for the presentation. Just a question on the suitability for the IETF. What I was trying to get my hands around is that, so the playbooks are there, and much of it is PDF, and as you said, and so forth. But then there's also automation that exists today in the corporations where they have, phishing, malware, viruses, and all of that, automated, running. So just want to make sure that I understand what you're proposing is that have a data model that sort of machine links all of these activities that are happening, that's ongoing all the time in the systems, but have some ways of data model that basically can sort of run these things in a way that the output from those machine, code that is running 24 hours to be able to sort of get the information, parse it, and present it, and then rerun. I'm just trying to envision how what the data model will do that really makes it an IETF work.
Yeah, so I know we're getting close to time, but in the long-term, long vision view, you would have an indicator fire through some means, and then that would connect to your graph. For threat intelligence, it could pull down a Cacao playbook for the targeted systems that you have, and then bubble that up into some sort of workflow process or through an orchestration tool, and then go through and start processing down the things that, maybe, your risk profile is you immediately block on your firewall and proxy automatically just right out of the get-go. And then if it's a system that you automatically re-provision that into a sandbox VLAN and you completely automate that. That seems like a very, it's a step that a lot of people do today. That might be a set of Perl scripts or Python scripts or something that is used to do that. But a lot of this happens today. And then, the reason why I think this might be IETF is we have over 70 some odd people in the room. And I think there's a lot of people that have interest here. And, I see this as being used across the internet in the form of being able to collaborate across ecosystems and trust groups that are not necessarily all inside with an organization. It does need to be standardized either in this SDO or another one, because we need to get vendor interoperability, between my company and maybe Alyssa's company.
I'm going to give you the hook in a second. Okay, so there's some notional boundaries about, can we define scope up on the screen? You guys all saw me type it while you were sitting here, so understand how long this has been looked at. So with that in mind, given some kind of rough boundary that looks a bit like this, can we get a show of hands for the chairs to understand, how many people think that this is a suitable area of work for the IETF at this point?
Alyssa Cooper, just for clarification. So the sort of trust model implicit here is anybody can send these to anybody. Yes. Okay. Thanks.
You may choose to only send them inside of a certain trust group, that you have. But the general idea is that organizations, could publish these and share them across. Instead of putting it on a blog post, you could actually share it through an ISAC or ISAL.
Or to anybody else on the internet.
Or anybody on the internet. You could literally publish it as some sort of data blob on a website and say, here you go.
Okay, thanks.
Think virus total.
All right, so can we get a show of hands? How many people think this is work that's suitable for IETF to tackle? Yeah, about 20 or so, roughly. Yeah, I was going to say. And how many people think this work is not suitable for the IETF to tackle? One. Two. What?
Readiness is my issue.
Practicability also.
I think I have two issues. Number one, I agree with Kathleen on readiness. Number two is this really does seem to be very closely related to the work that's going on in OASIS, and I'm wondering if they're the right people to do this before us, right? Because with the other work. So can you comment on that? What is that?
I have 3 minutes. I think that there is a group of individuals that we would like to bring into this work that are not in OASIS. And a lot of them are here in this room. So we like the expertise that exists in the IETF, and I think this is a little bit, I'm very familiar with OASIS and ITU, T's, Study Group 17, and IEEE, and to some extent, familiar with IETF, but I think that if it doesn't work here, then yes, we will have to go somewhere else.
Dave Woltemeyer from NIST. I'm a rep to the OpenC2 group in OASIS, and as that rep, I asked them if they would be willing to do this kind of work, and they said no, which is I think one of the reasons why Brett is here today, and
we have 1 minute, people,
and I feel like the IETF is a good home for this work if OASIS isn't going to do it.
Keep it really short.
Okay, Kathleen Moriarty. Since I said readiness, I think another iteration on this and building out, content and drafts and what this is going to look like and answering the questions that were raised today would go a long way. Thank you. It was a useful session.
Jessica Fitzgerald McKay, NSA. NSA chairs the OpenC2 work group, and we are very eager to actually see this portion of the problem be done in a more open, shareable environment rather than in Oasis.
Like 2 seconds, Mike Rosa, DHS. I also participate in Oasis, ITU, and IETF. And being in all three of them, I completely agree that IETF would be a better focus area for it.
Watson, very briefly, please, please, please do not be, let's reinvent Salt and Puppet. There's massive problems there, and I think that ultimately is where this work ends up having to go when you want to target stuff and you want to have commands, you want to work across systems. I work with a package managing system. There are problems in package management we haven't solved, so even just updating outdated versions of stuff is hard programmatically.
Like I said, we want to focus on what is done today and make that in a machine processable form. Doesn't mean it's 100% automated.
How many, can we get a show of hands? How many people think this problem is tractable? About 10. How many people think this problem is intractable?
I can't tell.
About 5, if I'm lucky, counting wise.
Hi, KSTP NCSC. Just I'm confused because when we first asked if people understand the problem space, there was a huge show of hands. Yes, I understand the problem space. And then I've heard some questions that may suggest you don't know the problem space. And we're asking if the problem is tractable or not. If you know the problem space, you should know. If so, you may be. I'm surprised by the lack of response on that last question, given the answers to do you know the problem space?
I think that's all we can ask at this point. Sorry.
How many unsure?
How many people need more information? How many people need more information to be able to answer the tractability? Yeah, let's go with roughly 20. Yeah, we will bring what we've learned from this to the mailing list. Hopefully that will refine the conversation and give us a way forward. Can I get the note taker to?
10 people said they thought it was tractable. 5 people, including some that couldn't tell for sure, said no.
Can you mic it?
Oh, I'm sorry. So 10 people thought they said it was tractable. 5 people, some of whom were vague, said it was probably untractable. And then I wrote most of the room, or maybe 20, said they were needing more information.
Yeah, it was 19.
19, okay.
Yeah, but roughly 20.
But we got a lot of answers, just to be a little more complete. We got a lot of answers on, the vast majority of the room thought they understood what the problem was, with few saying they didn't.
So there was a lot of talk about other work that could be leveraged here. I think part of the tractability for me, part of the reason why I think this is tractable is because I've seen some of the existing work that might be leveraged here, and I think that work actually makes this more tractable. I would encourage maybe some presentations on how this could leverage that additional work as part of maybe a next BOF.
Or how it does something different. Or virtual.
That's true too.
Who's got the other blue sheets?
Yeah, sure.
There would be